Finding rates of growth is an interesting and practical thing in economics. For example, finding the rate of growth of GDP, finding the growth of profits, finding the rate of growth of population, which is another variable that can affect the overall economy. So we can do this by using a simple mathematical tool which is known as the rate of growth, which is based on total and marginal functions. And for that we can use the exponential and logarithmic functions. Let us see how we can achieve this. So the purpose is to find the rate of growth, and we will be using the logarithmic functions and the exponential functions. Let us start with an assumption that we have a function, that is y as a function of t, and y depends on time, right? Because we are talking about variable y which is changing over time, so it's a kind of dynamic analysis. So after setting the function, we are going to find out the instantaneous growth rate, because it's talking about the change over time, so it's about the time that we are talking about. The formula is simply the derivative in the numerator and the original function in the denominator. We can write it like this, that is ft in the denominator and its derivative in the numerator. When we take the derivative, it becomes the marginal function, and when we write the function in its original form, it is the total function. So now let us calculate the values that we need to find out the final answer of how we calculate this. But before we go there, we can remember that a situation where the derivative appears in the numerator and the original function appears in the denominator is actually the derivative of a certain function, that is in this case f of x. So it means that we are indirectly talking about this situation, that is the derivative of natural log of x. This is in this case natural log of the function of x. So repeating this here, the function, its natural log and the derivative of it would be equal to the marginal function and the total function, that is the derivative and the original function. So we have found an equivalence. We can write this rate of growth by using some symbol, by using the ratio of the two derivative and the original function, by mentioning it in terms of marginal function and total function, or by mentioning it in terms of the derivative of a natural logarithmic function. So let's start with an example. V is a function of t, and we want to find out the growth rate of this certain variable, which is v. So for that, we will primarily calculate the natural log of that certain function. The function will be taken the natural log of by using the laws of logarithm, and then after applying this law, we get this answer. You can do this simply because natural log and exponent, they get cancelled out, and then we have this answer. So this is the natural log version of the given function. Now we simply have to take the derivative as per the definition that we developed. Now the derivative is to be calculated. So you can see the function on the left hand side and the derivative introduced on the left hand side as well as on the right hand side. When we take the derivative of this term, the first term, it will be 0 because a is a constant, whereas t is the variable under consideration, that is time. So its derivative will be equal to r. So 0 plus r is equal to r, and r is actually the rate of growth of the variable v, which can be an economic variable or any non-economic variable, but the purpose is served. We are able to find out the rate of growth of a certain variable. So in this way, we can apply this tool of finding the growth rate of a certain variable by calculating the derivative of the natural logarithmic version of the given function. And in the upcoming videos, we will apply this tool on various economic situations. Thank you.